There is a mountain so massive that it is literally bending the Earth's crust. Its sheer weight pushes the solid Pacific seafloor 8 kilometers straight down. It triggers earthquakes not because of moving magma, but from the simple, brutal physics of its own existence. This is Mauna Loa, the largest active volcano on the planet. For 38 years, it was completely quiet. That long, quiet stretch allowed immense pressure to build deep beneath the island of Hawaii. Then, in 2022, it woke up. The eruption that followed was a warning. Honestly, it was a best-case scenario and a lucky break that destroyed nothing important. But it revealed a chilling truth. For some people living on the island, if the next eruption breaks in the wrong direction, they might have less than 3 hours to escape. That is not time to pack or make a decision. It means you have to run. The volcano is changing again. After months of swelling, it has begun to contract like a slow planetary exhale. The question that volcanologists are asking, the one keeping civil defense planners awake at night, is not whether Mauna Loa will erupt again. They want to know what kind of eruption it will be. Will it be a slow-moving river of rock that threatens a highway, or a high-speed catastrophe that erases communities before sunrise? Mauna Loa was not born in a single violent explosion. It was built layer by agonizing layer over hundreds of thousands of years. It is a shield volcano, which describes its broad shape. It looks like a warrior's shield laid down on the earth. It covers 51% of the entire island of Hawaii. If you took all the other Hawaiian islands and pressed them together, Mauna Loa would still make up 85% of their combined landmass. Its summit sits at 4,169 meters above sea level, but that number is a lie. Its true base is on the ocean floor, 5 kilometers below the waves. From its crushed foundation to its frozen peak, the mountain is a staggering 17 kilometers tall. It is a planetary feature, not just a volcano. Since its first well-documented eruption in 1843, it has erupted 34 times. It is never a question of if, only when and where. For decades, one man made it his life's work to answer those questions. Dr. Thomas A. Jagger was a volcanologist who arrived in Hawaii in the early 1900s. He did not see a paradise. He saw a chain of islands sitting right on top of one of the most active volcanic hotspots on Earth. In 1912, he founded the Hawaiian Volcano Observatory. It was just a small outpost, perched on the edge of Klaua caldera, dedicated to the radical idea that volcanoes could actually be understood. He believed they had patterns and rhythms, and that their secrets could be read before they turned into disasters. Jagger was obsessed with Mauna Loa. He watched it, measured it, and listened to its deep seismic hum. He believed prediction was possible, and in 1935, he got his chance to prove it. The eruption began in the summit caldera, a vast crater named Moko Weo Weo. Soon, the pressure migrated and split the rock along the northeast rift zone. A river of basaltic lava began a slow march toward Hilo, the largest town on the island. Day after day, it crept closer. The flow was relentless. It consumed the ancient forest and sent plumes of steam and gas into the sky. Hilo's residents watched the orange glow on the horizon grow brighter each night. They were living on a timeline dictated entirely by geology. Jagger knew the town was doomed if the flow continued. The lava was advancing through natural lava tubes that insulated the molten rock, allowing it to travel for miles without cooling down or slowing down. He needed to break the plumbing system. His solution was audacious and completely unprecedented. He called the United States Army. On December 27, 1935, 10 biplanes from the Army Air Corps took off loaded with 600-pound demolition bombs. Their target was a lava flow. Jagger flew in a command plane and directed the pilots to the active lava channels. The plan was to bomb the tubes to break them open. This would force the lava to spill out sideways, where it would hopefully cool, solidify, and block the path of the flow behind it. It was a desperate gamble and an attempt to wage war on a geological process. The planes dropped their bombs. Explosions ripped through the black, hardened crust of the lava, throwing rock and molten material into the air. From the ground, the sound was deafening. To the residents of Hilo, it sounded like a desperate hope. Days later, the lava flow stopped. Hilo was saved. Jagger declared the mission a success, calling it a triumph of science and military precision over the raw power of the planet. But the story is not that simple. To this day, geologists debate whether the bombing actually worked. The eruption was already showing signs of weakening, and the volcano's output was diminishing. Many scientists believe the flow stopped on its own, meaning the bombs were just a loud, dramatic coincidence. The controversy remains, and it is a perfect metaphor for our relationship with Mauna Loa. It is a constant struggle to control a force that operates on a scale that makes human intervention look meaningless. Even the Thomas A. Jagger Museum, which stood for decades as a tribute to his work, was torn down in 2024 because the ground it sat on was too geologically unstable. On this island, nothing is permanent. The mountain has two distinct personalities, two pathways for destruction, and which one it chooses determines everything. The 1935 eruption that threatened Hilo came from the northeast rift zone. This is a long fracture in the volcano's flank, a weak zone where magma can easily push to the surface. Lava flows from this side tend to be slower. The slope is gentler, which gives the lava time to spread out and cool. It gives people time to watch, worry, and plan. In 1984, it happened again. After a period of intense earthquakes, fissures opened on the northeast rift zone. A massive lava flow began descending directly toward Hilo. For 3 weeks, the entire island held its breath. The lava advanced as a wall of black, clinking rock moving at a walking pace. It severed power lines, ignited forests, and painted a glowing scar down the side of the mountain that you could see from everywhere in the city. It came within 4.5 miles of Hilo's suburbs. It was close enough for residents to smell the sulfur, feel the radiant heat, and understand that their homes were days, maybe hours, from being incinerated. Then, just like in 1935, it stopped. The eruption ended, the pressure subsided, and Hilo was spared again. Then, Mauna Loa went quiet. For 38 years, the longest period of inactivity in its recorded history, the volcano slept. An entire generation grew up on the island knowing Mauna Loa only as a vast, looming shape on the horizon. It was a landmark, not a threat. But beneath the surface, the silence was a lie. Magma was steadily accumulating in the reservoir deep within the mountain. The pressure was building, and the ground was slowly swelling. The giant was taking a long, deep breath. The other side of the mountain is different. The southwest rift zone is not a slow-moving threat, it is a nightmare. This flank of the volcano is incredibly steep. When an eruption breaks here, the lava does not creep, it races. Gravity takes over, and the molten rock behaves like a river in full flood, channeled by the sharp terrain into a high-speed torrent of destruction. It is the single greatest volcanic threat to life and property in the entire United States. Communities like South Kona, Ocean View, and the fishing village of Maloli'i are built directly in its path. To understand the speed, you have to look back to June 1st, 1950. Just after 9 p.m., the southwest rift zone ripped open. Fissures miles long split the earth, jetting fountains of lava hundreds of feet into the air. The eruption was spectacular and terrifyingly fast. One of the main lava flows advanced 15 miles in just 2.5 hours. It was moving at an average speed of 5.8 miles per hour, which is faster than a person can run for any real distance over rough terrain. It reached the ocean in about 3 hours. 3 hours from the mountaintop to the coastline. It cut off roads, destroyed homes, and boiled the Pacific Ocean where it entered the sea. For the people living in South Kona, the 1950 eruption established a brutal, unchangeable timeline. If an eruption starts on the southwest rift zone after dark, you might wake up to find your only escape route blocked by a river of fire. The evacuation window is not measured in days or weeks. It is measured in minutes. 3 hours is not a worst-case scenario. It is historical precedent. That is the time it takes for Mauna Loa to reclaim its own coastline. This is the dual threat hanging over the island. You have a slow march of destruction on one side and a high-speed catastrophe on the other. For 38 years, both sides were silent. The island grew, the population expanded, and the memory of what the mountain could do began to fade. Until the night of November 27, 2022, just before midnight, the ground began to shake. Seismometers at the Hawaiian Volcano Observatory, led by scientist in charge Dr. Ken Hahn, went frantic. The summit of Mauna Loa was splitting open. The long sleep was over. The eruption began in Moku Weweo caldera, with a fountain of lava illuminating the night sky. For the first few hours, the eruption stayed inside the summit. But scientists knew this was likely just the beginning. The real question was where the magma would go next. Would it migrate to the northeast toward Hilo, or would it break southwest and trigger the nightmare scenario? The island waited. Hours turned into a day. Then the answer came. The eruption had migrated to the northeast rift zone. Hilo was in the path, but so was a critical artery for the entire island, the Daniel K. Inouye Highway, also known as Saddle Road. It is the main, and in many places only, corridor connecting the east and west sides of the island. If that highway were cut, the island's economy, supply chains, and emergency services would be severed. The lava began to flow. The primary output came from Fissure 3. It was astonishingly productive, pouring out molten rock at a steady peak rate of 100 cubic meters per second. That is enough to fill an Olympic swimming pool every 25 seconds. For 13 days, it did not stop. The lava advanced as a creeping tongue of black rock, its front glowing orange and red. It built its own channel, moving slowly but unstoppably toward the highway. Dr. Ken Hahn and his team worked around the clock to provide updates. They flew drones, took thermal readings, and modeled the flow's potential path. Their work was precise and calm, relayed in real time to civil defense. The world watched, fascinated. Helicopters full of journalists circled the flow, and tourists lined the roadsides, hoping for a glimpse of new land being created. But for the people who lived there, it was a slow-motion crisis. The lava front crept closer and closer to the highway, consuming everything in its path. Then it slowed down. The terrain flattened out, causing the flow to spread and stall. On December 10, the supply of lava from Fissure 3 dwindled. The eruption was over, and the flow stopped just 1.7 miles short of the highway. It was a geological near miss. In total, the eruption spewed 142 million cubic meters of lava, covering 36 square kilometers of land. The total property damage was estimated at a mere $1.5 million. Not a single home was destroyed, and no one was injured. Talmadge Magno, the Hawaii County Civil Defense Administrator, called it the best situation they could have asked for from Mauna Loa. It was a perfect eruption, in a way. It was a spectacular display of nature's power with almost no human cost. It was a dry run and a dress rehearsal. But it left behind a profound sense of unease. Everyone got lucky. The eruption chose the path of least resistance, the one that threatened infrastructure instead of lives. The next one might not be so accommodating, and it left behind a different kind of problem that would take years to solve. One of the casualties of the 2022 eruption was a single, lonely road, the access road to the NOAA Mauna Loa Atmospheric Baseline Observatory. This is not just any scientific outpost. It is the site of the world's longest continuous record of atmospheric carbon dioxide, the famous Keeling curve that proved to the world that the planet was warming. For decades, scientists have driven up that road to maintain instruments that are, without exaggeration, taking the pulse of the Earth. The 2022 lava flow buried that road under meters of black, jagged basalt. It was completely gone and totally impassable. For more than 3 years, science did not stop, but it became monumentally difficult. Scientists had to be ferried to the observatory by helicopter. Every piece of equipment, every spare part, and every technician had to be flown in and out. It was expensive, inefficient, and entirely weather-dependent. A critical climate record was being maintained by a thread. The director of NOAA's Global Monitoring Laboratory, Dr. Vanda Gruby, oversaw the challenge. The data was simply too important to lose. The task of rebuilding was immense. How do you build a road over a brand new, still cooling lava flow? Engineers had to find a stable path, crush the razor-sharp rock, and lay down a new surface. It was a slow, arduous process. Finally, on March 26, 2026, a temporary road was completed and land access was restored. Dr. Gruby called it a monumental win. It was a victory for science and a testament to human persistence, but it was also a stark reminder of how easily the volcano can rearrange our world. It does not need to destroy a city to cause chaos. It just has to bury a single road. Now, as of July 2026, Mauna Loa is quiet again. The volcano alert level is normal and the aviation color code is green. But it is not the same mountain it was before 2022. It is changing, and the data proves it. Following the eruption, GPS sensors planted all over the volcano showed the summit slowly beginning to reinflate. The magma chamber, having emptied some of its contents, was refilling from the deep mantle plume that feeds all of Hawaii's volcanoes. For months, the mountain swelled, which is a clear sign that the system was recharging. This is the normal, expected behavior after an eruption. Then, in June of 2026, something shifted. The swelling stopped, and the summit began to show a slight contraction. The mountain was, in a sense, exhaling. At the same time, earthquake activity dropped significantly. In May 2026, scientists detected 170 small earthquakes in the summit region. In June, that number fell to just 94. The volcano was growing quieter and calmer. What does this mean? No one knows for sure. A contraction could mean that the supply of new magma from below has paused, or it could be a temporary fluctuation in a much longer cycle of recharge. As Dr. Ken Hahn often says, scientists are trying to gently coax a volcano story out of the rocks and minerals. Right now, the rocks are telling a complicated story of a recharge followed by a sudden pause. Adding to the complexity was a major tectonic event on May 22, 2026. A magnitude 6 earthquake struck beneath Mauna Loa's western flank. The alert went out immediately. People wondered if this was the precursor to a new eruption or if magma was moving. Scientists quickly analyzed the data and realized the quake's signature was wrong. It wasn't volcanic. It was the result of the Pacific plate bending under the colossal weight of the island itself. It was the mountain, simply by existing, breaking the foundation of the earth. It served as a powerful reminder of the forces at play, entirely separate from the magma churning miles below. The 2022 eruption did not relieve the pressure on the volcano. It was a small release from a much larger, and still filling, system. The Northeast Rift Zone erupted, but the Southwest Rift Zone remains primed. The terrifying math of the 1950 eruption has not changed, and the 3-hour window for South Kona has not gotten any wider. Every piece of data is now scrutinized. The slight contraction of the summit and the decrease in small earthquakes are not necessarily signs of safety. They are just the latest chapter in the volcano's long story, a pause in the narrative. The silence on Mauna Loa is not emptiness. It is the sound of pressure building and the next eruption gathering its strength. The lucky break of 2022 was a warning. The next time the fissures open, the lava may not flow toward an empty stretch of land, and it may not stop 1.7 miles from a highway. It may turn south. And the clock will start ticking, not in days, but in hours or maybe less. The instruments will provide a warning, and the scientists will issue the alert, but they cannot stop the flow. They cannot bomb it into submission. All we can do is watch and hope everyone gets out of the way. The mountain that is so big it bends the crust of the earth does not negotiate. It simply moves, and the only question left is which way it will go.